Okay. Maria, will you read the instructions for us for numbers 1 and 2?
Show the conjecture is false by finding a counterexample.
All right, here comes the first conjecture. Number 1, Raymond, read it for us, please.
If the product of two numbers is positive, then two numbers must be negative.
Okay, thank you very much. So it's saying if the product of two numbers is positive, kind of like this. Let me give you an example of what you're showing. Let's say negative 2 times, let's say negative 5. And that's going to be what?
10.
It's going to be 10. So that's what they're saying. They're saying if the product is positive, then the two numbers must be negative. Can anybody counter that? Kelly? Absolutely. Here's a counter. I'm going to put the counter in red. Counter. 2 times, what do you say, 2 times what? Yeah, 2 times 2. Two positive numbers here. Positive, positive. And that gives us a positive result. So that's a good counter. Got another one?
I just have a question.
Go ahead.
If this was on a quiz, we don't have to write anything except for just something that counters.
Exactly. You just have to show me this, and that's all I need. All right? So this is what they're proposing. Has to be true all the time, but it's not always true. So I'm just going to say it's not always true. All right? Let's take a look at another one. Number 2. Nick, read the conjecture for us for number 2.
The sum of two numbers is always greater than the larger number.
Okay, so what they're trying to say to us is that the sum of two numbers, let's say we take the numbers 3 and 7, and they're saying if we add those two numbers, 3 plus 7, we always get a number which is going to be bigger than the larger number 7. I wonder if someone can successfully counter that for us. Joel, you think you can?
Yeah.
All right, let me write counter here. What is it?
Negative 3 plus 7 equals 4.
All right, a negative 3 plus 7 is equal to 4. That's correct, because 4 is not larger than 7, is it? Yes, and 4 is certainly not larger than, and that's what that means, not larger than 7. So that's a good counter. Can someone give us another counter for that? Two numbers added together where the sum is not going to be larger than the bigger one. Go ahead, Raymond.
5 plus negative 1 equals 4.
Yes. Another one would be like that. If I do 5 plus a negative 1, that's not going to be bigger than 5. It's going to be 4. Yeah, so we got 2 successful counters there. Let's take a little bit more practice in here because I think I've got a couple questions like this on the quiz. So let me go forward and see if I can give you a couple more to practice. Here we go. Seek a counterexample. This is on page EP4 in your books, number 7. Austin, read this conjecture for us, number 7.
The difference between two numbers is a value that lies between those two numbers.
So essentially what they're saying, difference. Difference means what again, Janice? Add or subtract? Subtract. So if we're subtracting two numbers, let's say we're subtracting 2 from 7 like this, they're going to say, oh, we're going to get a number which is between 2 and 7, which is 5, and that would be right, but is that always the case? Who can counter that? Difference between two numbers, which is not a number between those two numbers. Andrew, can you think of a way of countering this? No? Go ahead, Robert.
8 minus 1.
8 minus 1.
No, 8 minus 7.
8 minus 7.
Yes. Equals.
let me see, 8 minus 7 equals 1. Yeah, and 1 is and 1 is not between 8 and 7, you're saying?
Yes.
Yeah, that would be a successful counter. Anybody's got another one? Joel, you think you got one?
4 minus 5.
Four-
5 minus 4, sorry.
5 minus 4. Let me try that. 5 minus 4. I think that'd be good. 5 minus 4. That'd be similar. That'll be 1, and 1 is not between 5 and 4. Between 5 and 4 would be something like 4.5, right? How about negative numbers? Ben, can you give me one negative numbers? Subtracting a negative number?
Well, I was just gonna do 9 minus 5, but I didn't really want to answer.
Kelly? Yes. I was waiting for something like this. Negative 10 minus negative what? 10. That's a good one. What's between negative 10 and negative 10? This would be like negative 10 plus 10, which would be 0. And you might say, well, 0 is between negative 10 and 10. So this might not be a good one, Kelly, because 0 is actually between negative 10 and 10. So I want to take that one off.
Negative 10 minus the negatives.
Yeah, let me take that one off. All right. Let me propose one to you. Let's say 8 minus negative 2. That would be 8 plus 2. What's that?
10.
That would be 10. And 10 is certainly not between 8 and negative 2. So that one would also work. All right, finally, let's take a look at this conjecture and see how we could refute this one. Caitlin, read it for us, number 8.
The value of zx is always greater than the value of x.
It's actually 2. I didn't make it properly. 2x. No, I'm sorry, 2. Go ahead. So the value of 2x is always greater than the value of x. What's that saying? It's saying that the value of twice a number is always greater than the number itself. For example, if I take, let's say I take 2 times 5, you're saying equals 10. It's always going to be greater than 5. Is that always true? Okay, somebody give me a counter. Raymond, again, go ahead, Raymond.
If x was equal to 1, it'd be 2 times 1, which is, if x equaled 1,
Uh-huh.
and
And 2 times 1 would not be greater than 1? It would be. Yeah, try again, try another one. Think you got one? Okay, go ahead, Andrew. I want to give somebody else a chance, Joel. And you,
Times 0.
2 times 0?
Yeah, sure.
2 times 0 is 0. You're saying this is not greater than 0? You're right. That would be a good one. Joel, you got another good one?
Yeah, negative, or 2 times negative 5.
That would be an excellent one. What's that?
Negative 10.
Negative 10, which is certainly not greater than negative 5, because negative 10 is way to the left on the number line. Yeah, so that's a good one. All right, I think we've done enough of that. Let's go ahead and do something different now. All right, number 4. Go ahead for me, please, Noah, and read instructions for number 4 from page 85, number 4 and 5.
2x minus 8 equals 2 because x equals 5.
What are we doing? Instructions. No, read me the instructions.
Oh, in exercise 5, write the if-then form and the contrapositive of the statement.
All right. Yeah, let's go ahead and do it with this one. What color should I use? Somebody give me a nice color. What should I use?
green.
Purple? All right. So listen carefully now. 2x minus 8 equals 2. I'm making my 2's like these. Because x equals 5. Who can transform that or change that for me into the if-then form? If-then form. Tina?
If 2x minus 8 equals 2, then x equals 5.
Good try, but this because here is kind of like it's hanging on this. It's hanging on this. So we're going to have to use this up front. Jake? We're looking for if-then form. Come on, you can do this. If,
Would it start with 2x minus 8 equals 2? Like if
No.
2x minus 8
No.
equals 2.
look at this word right here.
Equals 5.
Go ahead, Maria.
If x equals 5, then 2x minus 8 equals 2.
Exactly. If x equals 5, then 2x minus 8. Okay, Caitlin, what do you have in your hand? Bring it. 2x minus 8 is going to be equal to 2. Okay. All right. Pay close attention now. So that's the if-then form. All right. What else are we doing with this? Noah, what else are we doing? What did they say we should do? Just find the if-then form and what else? Contrapositive, right? Contrapositive. Okay. We can easily find the contrapositive from the converse. So let's take the converse first, and then the contrapositive is going to be the inverse of the converse. Let me take another color for the, what should I use for the converse here?
Green.
Green? All right. All right, who can give me the converse quickly? Austin, what's the converse of this?
If 2x equals 8 minus 8 equals 2, then x equals 5.
Excellent. Glad you remember that. 2x minus 8. You're going to see this tomorrow. I'll tell you right now. Equals 2. Then x is equal to 5. That's the converse. I'm looking for my contrapositive, which is the inverse of the converse. In other words, it's the negation of both the hypothesis and the conclusion. Who's ready? Go ahead, Caitlin.
If 2x minus 8 does not equal 2, then x does not equal 5.
Excellent. So here it comes. If 2x minus 8 is not equal to 2, then x is not equal to 5. Okay. That's and let me just go a little bit further. Who could give me the inverse? Inverse. I know they didn't ask us, but this is a good way to study to anticipate what you're not even asked. Who can give me the inverse of this conditional here? Janice, what's the inverse? Excellent, good start. X is not equal to 5, then what?
Then 2x minus 8 is not equal to?
2x minus 8 is not equal to 2. That's the inverse. All right, yes.
Would you prefer we'd write is not equal to, or do the equal sign with the slash?
When it's algebra like this, you're going to strike it through like that. All right, let's take this last one here. I think it's just regarding reasoning now. Instructions for number 5. Who can read that for me quickly? Number 5. Joel?
Make a valid conclusion about the following statements. If it is above 90 degrees Fahrenheit outside, then I will wear shorts. If it is
All right, stop right there. So assuming that this is true, we're going to go ahead and take a scenario and use this to make a conclusion. If it's 90 outside, then I'll wear shorts. What's the scenario? Read it now, Joel. What's the scenario? What do we have? What?
what do you mean?
it is,
Oh, if it's 90 degrees.
no, you already read that. It is what? What's the temperature outside now?
98.
It's 98. It's 98. So what's the conclusion? You will wear shorts. You will wear shorts. That's the conclusion.
It's in the
What is
book.
that for?
All right? So that's the law of detachment, just based on one conditional. Another one I gave you was called the law of syllogism, based on two conditionals. Remember that one?
Yeah.
Two conditionals. All right. I think this is pretty much it.